Hey everyone, welcome back to our channel. Today we're diving into an often overlooked but extremely important aspect of electrical systems, ground grid testing and maintenance. It's something many people don't know about, but it's crucial for the safety and reliability of our electrical grids. So whether you're a seasoned electrician or just curious about how our electrical systems stay safe, stick around. We've got some great info coming your way. Why is it so important? Imagine for a moment you're working on a large construction site where heavy machinery and tower cranes are in operation. The last thing you want is for someone to get injured due to a faulty electrical connection. That's where the ground grid comes in. This extensive network of conductive material buried beneath the surface is the unsung hero of electrical safety. Its primary purpose is to provide a reliable path for excess electrical energy to return to the source in the event of a fault. This simple mechanism significantly reduces the risk of electric shock, protecting both workers and the environment from harm. But here's the catch. Like any complex system, the ground grid is foolproof and requires regular maintenance and testing to ensure it is functioning at its best. One tiny oversight could have serious consequences. Picture this. You're working on a live electrical circuit and suddenly everything goes wrong. Equipment is damaged, lights go out, and worst of all, there's a risk of injury. These scenarios aren't just theoretical. They happen in real life, often when electrical systems aren't correctly grounded. That's where ground grid testing comes into play. By regularly testing the ground grid, we can confirm that it's providing the necessary level of protection. We're essentially giving our electrical system a health check, making sure it's ready to handle any unexpected issues that might arise. This practice ensures that in the event of a fault, the excess electrical energy will be safely directed back to the source, minimizing the risk of damage and keeping everyone safe. Now let's dive into the nuts and bolts of ground grid testing. What does this process actually entail and why is it so critical? First off, understanding what a ground grid is and how it functions is key. Buried around structures, these grids typically consist of a network of connected conductive materials such as copper or aluminum. Now the big question, what exactly does a ground grid do? Well, its main purpose is to provide a low-resistance path for fault currents to flow, acting as a sort of safety valve for our electrical systems. When a fault occurs, this allows the excess electricity to return to its source without causing damage or posing a risk to humans. Think of it as an insurance policy for your electrical setup, always there in the background, ready to take action when needed. But how do we test this system to make sure it's always ready? Enter the ground resistance tester, a specialized tool designed to measure the resistance of the ground grid. The lower the resistance, the better, as it indicates a more efficient pathway for the electricity to follow during a fault. These tests are not one-off procedures. They should be performed regularly to account for factors like soil changes, corrosion, or shifts in the grid itself over time. By keeping a close eye on these readings, we can spot issues early, preventing small problems from turning into major headaches down the road. Let's look at some best practices for ground grid testing. Before we jump into this, remember to hit that like button if you find this info helpful. Your support means a lot to us. Thanks for being awesome. First and foremost, qualified personnel should always carry out ground grid testing. This isn't a DIY project. It requires expertise to ensure accurate readings and safe practices. Additionally, the testing process should adhere to recognized standards and codes, such as those set by OSHA or the National Electrical Code. These guidelines provide a framework for ensuring that the testing is thorough and reliable. The frequency of testing depends on various factors, including the size of the grid, environmental conditions, and local regulations. As a general rule, it's recommended to test the grid at least once a year. This helps to catch any potential issues early before they escalate into significant problems. Different testing methods exist, each with its own set of advantages and use cases. Some common ones include the fall of potential method, which involves injecting a known current into the grid and measuring the resulting voltage drop. Clamp-on methods, as the name suggests, use clamps to attach current and voltage sensors to the grid conductors, allowing for non-invasive measurements. Specialized software can also be used to analyze the data collected during testing, providing valuable insights into the overall health and performance of the ground grid. By utilizing these tools, electrical professionals can ensure that the grounding system functioning as intended, providing the necessary safety and reliability for the entire electrical network. Now let us talk about some common issues that can arise with ground grids and how to avoid them. One frequent problem is corrosion due to factors like soil type and moisture. This can degrade the grid's effectiveness over time. To combat this, use corrosion-resistant materials for the grid and implement cathodic protection systems. Regular inspection can help identify corrosion early, allowing for prompt maintenance. Another issue is loose connections. Whether it's due to vibrations or shifting soil, loose connections can interrupt the flow of electricity, compromising the grid's integrity. Employing torque-controlled tools during installation can help ensure tight, secure connections. Visual inspections and periodic testing can then verify that these connections are maintained. Soil changes, including erosion or shifting, can also affect the performance of the ground grid. These changes can alter the grid's resistance, impacting its ability to conduct electricity effectively. Regular monitoring and adjustments can keep the grid's resistance within acceptable limits, ensuring optimal performance. By staying vigilant and proactive, electrical professionals can mitigate these issues, ensuring the ground grid continues to function as a robust, reliable safety mechanism. Speaking of maintenance, how often should we be checking and maintaining our ground grid systems? Well, there's no one-size-fits-all answer to this question. It depends on several factors, including the size of the grid, the environment it's in, and local regulations. However, a good rule of thumb is to inspect and maintain the ground grid at least once a year. During these checkups, it's important to look for signs of corrosion, damage, or loose connections. If any issues are found, they should be addressed promptly. Remember, a well-maintained ground grid is a safer ground grid. Let's discuss some effective ways to maintain our ground grid systems. Regular visual inspections are crucial. Trained professionals should check for any signs of damage, corrosion, or loose connections. This can often be done using specialized cameras or other non-invasive techniques, ensuring the safety of both the inspectors and the equipment. Additionally, performing routine resistance tests is essential. As discussed earlier, these tests can identify issues like increased resistance due to corrosion, soil changes, or other problems. Addressing these issues early can prevent minor problems from becoming major headaches. Implementing a schedule for these inspections and tests is also key. By setting up a regular maintenance plan, we can stay ahead of potential issues, ensuring that the ground grid remains highly effective over time. By following these maintenance practices, we can help ensure that our ground grid systems continue to operate efficiently, providing the necessary safety and reliability for our electrical infrastructure. We hope you found this info on ground grid testing and maintenance useful. Remember, a properly functioning ground grid is essential for the safety and reliability of our electrical systems. By understanding the importance of ground grids, implementing best practices for testing and maintenance, and addressing common issues, we can help ensure that our electrical infrastructure remains safe and efficient. Thanks for tuning in. If you'd like more content like this, hit that subscribe button. Your support really helps us grow. Stay safe and keep those systems grounded. Until next time.
So now, a bit about me. My name is Mike L., and I am an experienced electrical engineer who has worn many hats, holding key roles in projects, engineering, planning, operations, asset management, maintenance, and field resources development. I design and pioneer engineering solutions to propel the utility and energy industry forward. My passion within the industry has also driven me to develop educational materials for the new generation of utility and energy professionals. The knowledge I teach is not only based on my own experience within the power utility industry, but also on knowledge gaps identified by other professionals in the field. Learning from me will provide you with the comprehensive, fundamental knowledge you need to kickstart your professional career in the utility industry. If you are interested in what I have to teach, check out my courses at Udemy and connect with me on LinkedIn, X, and Facebook. Don't forget to comment, like, and subscribe this video. Bye for now.